we have to go a bit more in detail about how this happened and like the different neurons and the different neurotransmitters that are going to be involved in these two mechanisms, okay? So first of all, we are going to start with the, like both for the sympathetic and the parasympathetic nervous system, everything is going to happen in the brainstem. Okay, so this is the part of the brainstem, right? So then to the brainstem, we are going to have some stimuli that is going to be sensed by the different receptors in our body, and then this stimuli is going to be carried to the brainstem by the afferent neurons. So the afferent neurons bring this stimuli from the receptors into the central nervous system, okay? And then what is going to happen is the brainstem is going to, through the efferent neurons, is going to innervate these different systems and organs and produce the response that we want, right? So this is done through the efferent neurons we have seen that innervate the rest of our tissues and organs that we have here, okay? But there are there are a lot of differences between the sympathetic and the parasympathetic nervous system in terms of the efferent neurons that are going to innervate the different systems here, right? So in case of the sympathetic nervous system, all the these nerves, so these motor nerves, are going to come from positions T1 and also L3. Okay, so that's the first difference. In case of the parasympathetic nervous system, these nerves are going to come here from the cranial region, or from here for the back of our spine here, that is called the sacral region. Okay. So let's look a bit more into detail into the neurons and the differences between the neurons in the sympathetic and the parasympathetic nervous system. So here in the sympathetic nervous system, we have the first difference is that we have a neuron here, so an efferent neuron. So this neuron is going to perform the synapses to the next neuron into something that is called a ganglion. Okay, so because the synapses is done in the ganglion, we have a preganglionic neuron and then a postganglionic neuron, okay? The preganglionic neuron is very short, and the postganglionic neuron, that is the one that is going to innervate directly these tissues, is very long. That's the first anatomical difference. So let's make it longer here, so we see this clear. So this is longer because this is going to innervate directly the different tissues that we have here, and the organs, okay? So in comparison to the parasympathetic nervous system, this is different, right? So we also have two neurons, but these synapses here, this synapses here is done directly at the tissue in which we want to innervate, okay? So in this case, this preganglionic neuron will be very large, and this postganglionic neuron will be very short. So it's the opposite as in the sympathetic, where like the first neuron here is short and the final neuron is very long. Okay, so that's the first difference. The second difference comes with the neurotransmitters and also the different receptors. So here in this first synapses, the neurotransmitter is acetylcholine, and this is the same as here. So the receptors that we are going to have in the postganglionic neuron, they are nicotinic receptors, so N2 receptors, and the same here, we are going to have the N2 receptors. But then the difference happens In this second synapses here, there is a synapses that is going to directly stimulate the tissue. That is here in the parasympathetic nervous system is going to also be acetylcholine. So the receptors in the cells in the tissue are going to be muscarinic. So that's M. But here is different. This is going to be adrenergic. So the neurotransmitter here is called noradrenaline. NA. And then the receptors here at the tissue are going to be adrenergic. So this is very interesting because we have different neurotransmitters, so we can use different drugs that are going to target specifically this neurotransmitter to have a specific effect on the tissue that we want to control, right? So this is very interesting from a pharmaceutical point of view, okay? So also, before we finish with this video, I want to drive some importance to the adrenaline. So the adrenaline and the noradrenaline are very important molecules because they are going to be the ones that are going to be mediating this fight or flight response, right? So in the case of noradrenaline, so we have the preganglionic neuron, then the postganglionic neuron, and finally this postganglionic neuron is going to secrete the noradrenaline that is going to have the impact in the tissue. But in the case of the adrenaline, we have just one neuron that is going to go directly to innervate the suprarenal gland. So this is a small gland that is here on top of the kidney. And then this gland is going to release the adrenaline to further increase that response of the noradrenaline. So this is why when we are driving in the night and we see a deer and we almost hit it, but we were able to react very quickly, we were able to do the fight or flight very quickly, right, and we don't hit it, then this is going to be continuing. We are going to feel anxious for a bit because we have the joint or synergistic effect of the adrenaline and the noradrenaline. The noradrenaline that is here secreted by the postganglionic neurons, and also the adrenaline that is here secreted by this gland in the kidney. Okay, so I think this is all for today. I hope you enjoy this lecture and you enjoy my beautiful drawings about the different systems in our body. I'll see you next week for more stuff about the neural system. Thank you.